When we're creating programs, we often have to check if one thing is less than or greater than the other, or do two things match? Do they have the same value? Those kinds of things. And we can do that in Python, just like every other programming language. So we'll take a look at the comparison operators, like greater than, less than equal, those kinds of things. And we will control the flow of our program using if, else if, those kinds of things. So easiest way to look at a bunch of different comparisons is just to run Python to get to our interactive interpreter. And a lot of the symbols are what you might expect. So if we run 5 is greater than 6, this is going to return true or false. So notice capital F, false, that's a binary value, Boolean value, true or false, capital T, capital F. So 5, you can ask the question, is 5 greater than 6? No, that's false. Is 5 greater than 3? Yes, that is true. So sometimes turning it into a question in your mind can be helpful. Greater than or equal, we just combine the greater than with the equal sign. So is 100 greater than or equal to 100? Yes. Don't include a space between that greater than and the equal sign. Just mash them together. Is 100 greater than or equal to 99? Yes, should tell us that that is true. Is 100 greater than or equal to 200? No, that is false. Here we're just comparing numbers. Very frequently we'll be using variables that we don't know the values. Our program doesn't know the values beforehand, but when these expressions are actually evaluated, this is what Python will be comparing under the covers. So fairly intuitive. Is 8 less than 10? Sure is. That, yes, true. Is 10 less than 8? It is not. That is false. I'll fix that typo in post. Moved from one format to another. Less than or equal to, don't put that slash there. All right, Jedi mind trick, you did not see the typo. Through the magic of source code management and my service provider, I fixed that typo. One typo up at the top was okay. 2 typos for the same thing? No, not good. All right, less than or equal to. Is 1 less than or equal to 100? Indeed, that is true. So again, don't put a space between the less than and equal. So the whole statement will evaluate to either true or false, that single value. Now, when we create variables, like if I create cat equals Alice, the single equal sign, we use that to assign variables in our program. So a frequent mistake when people want to compare two things, they might use the equal sign. So if 42 equals 42, it's like, what? Python's like, no, that's not cool. It says maybe you meant equals equals instead of just 1 equals. Indeed, Python, you are correct. Your error message is accurate. 42 equals 42. That's true. Now I don't need the space between the before and after those double equals. I could do it just like that. That's perfectly fine. Either way, stylistically, it works. Now to check if something is not equal, here's where some programming languages do it differently. If we want to say, is 42 not equal to 42? Here we've got a double negative. It's false because 42 does equal 42. So exclamation point equals, that's the not equals. Is 41 not equal to 42? Yes, it's true that 41 is not equal to 42. Very frequently in our programs, we will be using variables to evaluate all of these things. So if I say small equals 5 and large equals 100, our comparisons will frequently look something like this. Small equals large. That's false. The value of small does not equal the value of large. Small not equal to large. Yeah, they're not the same. They don't have the same value. That makes sense. Is small less than large? Looking at the names, that should be true, and indeed it is. Is small greater than large? No, it is not. Is small less than or equal to large? Yep, sure is. But is small greater than or equal to large? Nope, it is not. We can compare strings too, like if I say person 1 equals Alice and person 2 equals Bob. Does person 1 equal person 2? No. Greater than or less than wouldn't really make sense here, but I might check if they're not equals. Like if you're comparing, like, is the password that the user entered, is that the same as the password we have in our database? You could compare two strings. So you can use these comparison operators with things other than just integers, and it works just fine. All right, I'm going to exit out of my interpreter, exit there, and I've got Visual Studio Code running because we're going to look at more complicated programs now. And while you can run this in the interpreter, it just gets confusing. Just trust me on that. Let's create a new file here. I'll use the new file icon, and I'm going to call this if.py. It'll open this code up for me right here, which is good. And we'll write out that code. I'll pause the video while I type all that out. All right, unpause. I cheated. I copied and pasted. I would encourage you to type it out though, because it forces your brain to slow down and pay attention. But let's take a look at the code. We're creating a student score variable, and here we're requesting some input. Notice that that input is wrapped with the int function. So whatever the input is, it's going to be converted into an integer. Then we're going to check, does that student score variable have a value over 500? If so, we'll print one message out. But if the student score is only greater than 400, but not greater than or equal to 500, we'll say they almost made it, they get a free retake. Otherwise, if the first two don't get triggered, if we didn't get a true value in either of those places, no matter what, at the end, it'll print the student needs to study more. So this is an if, elif, else block. So some things to notice here. We start line 2 with the if statement, and then followed is the comparison. That's the statement that must evaluate to either true or false. At the end, once we've done our comparison, we use that colon character. So after that colon character, notice that we indent the code 4 spaces. Python, you have to indent that code. Anything indented within this if block will be run only if the statement being evaluated there in that condition is true. So the way this logic works, this first if statement, if that's true, nothing else in the elif or else is going to run. But if this is false, the program will continue on line 4 with this elif. So that stands for else if. But it's similar that we have a statement here that must evaluate to true or false. Is the student score greater than or equal to 400? If so, we give a different message. If we get to line 4, we know that the score is not greater than or equal to 500. So if the score is not greater than 500, it's not greater than or equal to 400, then we have this catch-all block here at the end, this else. Again, we've got that colon character at the end. It's really easy to forget that colon character. It'll say the student needs to study more. So no matter what number we put in there, we should trigger one of these 3 print statements. So we can test this code, and I'll expand this because the input line is pretty big. I'll run this code. Please enter the student score to evaluate. So this student, let's say, got 650. The student made it. Okay, because it's greater than or equal to 500. Let's run this code again. If I enter 500, I should get that same message according to the logic. And yes, the student made it. I'll run the code again. Enter the score to evaluate 499. Almost there, the student earned a free retake. So because 499 was not greater than or equal to 500, Python went to this elif statement. And it says, okay, is 499 greater than or equal to 400? Yeah. So it will print that statement. Run it again. If I enter 400 here in the input, also gets a free retake. Good. Anything less than 400 should trigger a, 399. Student needs to study more. I'll run it again. 0. Student needs to study more. What do you think is going to happen if I put a string in there like FIVE? Try it out. See if you can figure out what's going to happen. FIVE. Well, can't do it because the int function is looking for digits, basically. Didn't work. As expected. So our program is not perfect. It doesn't do very detailed checking. Now, it's important that you test your own code, test your logic. So what I did was try to test all of the different edge cases to make sure that my logic is correct. It's really easy to use greater than when you really meant greater than or equal to, or to use less than or equal to when you really meant less than. So it's important to test the logic of the program. Now, you don't necessarily need to have an if, elif, else pattern. You could have a program that just has an if statement, for example. So I just deleted the code there. And I'll start over. Name equals Bob. So my program could check if name, so name is a string. So if I say name 0, that will, what will that do? That's going to check the first character equals B. What should I do? Visual Studio Code indents this for me, which is helpful. I will print the name starts with a B. Very clever program. Then I'll print done, just to make sure we know that our program actually ran, because if the name does not start with a B, we might not see anything. We wouldn't see anything unless we had line 4. So let's go ahead and run this code. And yeah, the name starts with a B, done. If I just change this here to Charlie, run this code again, all it does is print done. So this is perfectly valid. Just have an if statement that will do something under one condition, and then you're just finished. We can run this next sample code. This has if and else, but it has no elif. And I'm gonna be lazy. My right click is being super slow right now. I'll delete all that code and just replace it here. I'm just going to make sure, yeah, my 4 spaces did paste correctly. You have to be careful pasting things in because Python's kind of picky about its indentation. So here, name is Alice. If name starts with B, we'll print one message. Otherwise, else basically means otherwise, print the name does not start with a B. So no matter what, we should get one or the other printed out. And I think you can probably guess what this will print. Yeah, sure, Alice does not start with a B. We also can have multiple elif statements. So for example, this code, what does it do? So we have a name variable. So it's going to do a lot of different checks here. So if that first character in name is a B, print starts with a B. If that's not true, it'll go to the elif. Check the first character, see if it's an A. If that's not true, it'll go to the next check and see if the first character is an E. So I could have technically dozens or hundreds of elif statements in one really big block. It wouldn't look good, might not be a great practice, might mean I need to rethink the way my program is formatted, but this would work. Then we have that catch-all at the end, that else. If nothing else was true, it will run this at the very end. So if I run this code, the name does indeed start with an E. Let me change it to Pat. The name does not start with B, A, or E. Indeed. In these examples so far, we've been comparing one value to another, but sometimes we need to compare multiple things at the same time. Let's jump into the interactive interpreter for this part right here. Run Python, we get our interactive interpreter. I will just minimize for right now Visual Studio Code, and I'll squish down my interpreter here. Let's say we're looking at college admissions. We have grade equals B and status equals junior. So we're using the single equals sign here to assign those values to those new variables that we created. So we can use and to compare multiple things together at the same time. So if I have grade equals B, so that's a comparison, that will return true or false. And status equals quote senior. When I run this, notice that a single statement is output, a single Boolean variable, false. So grade equals B, that's true, and status equals senior, that's false. So true and false, both of them have to be true to return true. Because one of them was false, we get the value false right here. So this says all of these things have to be true to return true. With and, if we're comparing multiple things, if there's a single false in there, the whole thing is going to be false. If we change that though, I'll hit the up arrow key, change that and to or, it will tell me that's true. So grade equals B, that is true, or status equals senior, that is false. With or, if any of these comparisons are true, the whole statement is true. So this is a very important distinction. This kind of logic is what attackers sometimes use to try to break applications. If they know that they can inject an or somewhere and make a statement true, they can mess with applications. That's at the heart of many database SQL injection attacks. If you're not sure what SQL is, that's fine. We haven't covered it. Let's take a look at this big, long comparison. Will this be true or false? If you just right-click in your PowerShell prompt, it'll paste. So 1 equals 2, no. Or 2 equals 3, false. 3 equals 4, that's false. 4 equals 5, that's false. 5 equals 6, that's false. 7 equals 7, that's true. But this whole expression will generate one single output, either true or false. So what's it going to be? It's going to be true because 7 does equal 7, and we're using the OR. So it's checking to see if any of those are true, then the whole thing is true. Let me copy this code down here using ands, these multiple comparisons. And I didn't copy it correctly. Let me recopy that. So I'm going to right click in here to paste. It tells me it's true. So 1 equals 1, true. 2 equals 2, that's true. 3 equals 3, that's true. 4 equals 4. 5, oh, I'm sorry, I threw an OR in there. Because I threw that OR in there, it threw off the whole thing. So I didn't remember that I'd stuck that little Easter egg in there. Or 7 equals 7. So despite the fact that many of these were true, I used an AND here, which means that they all have to be true to return true as a total statement. That OR at the end, or 7 equals 7, in this case, that's the one that really matters. Now this logic can be hard to parse. So sometimes what we'll do is we'll use parentheses just to group comparisons. So here's an example. Name 1 equals Bob. Name 2 equals Alice. We can group comparisons using parentheses. So name equals Alice and 1 equals 2, or name 2 equals Bob and 5 equals 5, parentheses. So when I run this, what should we get? We get a syntax error, 2 typos. Yikes. Name 1 equals Alice and name 2 equals Bob. Okay, so it tells me that is false. So the astute person, I'm going to fix this code right now. Name 1, we set name 1 to Bob, so let's change this to name 1 equals Bob and 1 equals 2, and name 2, let's change that to Alice. So let's take a look at this statement now. Name 1, the value is indeed Bob, but 1 does not equal 2. But in the second comparison, name 2 is Alice and 5 equals 5. So what's that going to be? That will be true. So together, this first that's false, but in the second parentheses, that's true. So the whole thing is going to be true. And by the time you go to this page, I just pushed the update to fix that little whoopsie daisy. The web page will be fixed. So the concepts still apply. The code worked, just I had a couple of typos in my example there. So these control statements are very useful for building applications, checking if something worked, if something didn't work. I started Visual Studio Code. I'm going to close the welcome, access my file explorer. I'll open a folder and I'll go to my desktop. That's where I put my Python documents. I'll select that folder. I would encourage you to check out the exercises here, looking at conditionals, if integer comparisons. check if A is equal to B, and if so, do something. So write out those statements. Check if A is not equal to B. So A does not equal B. Those types of things. See if you can fill out that code, do those exercises, because every programming language everywhere is going to have these kind of control statements that help you decide what actions to take depending on the values of your variables.